Thank you. Thank you very much for the introduction, Anders. It's a bit of a mouthful what I'm going to talk about, but no worries, I'm going to work you through every part of this title. So we're going to talk about shared responsibilities and collaborative research and innovation approaches, ensuring safe and sustainable products and processes throughout complex value chains. So by the end of the presentation, we will have spoken about every one of these different aspects, but I promise I get you out very, very soon. It's actually not that difficult. You can see from this, do I have a, I do. You can see from this logo on the bottom here, and you heard a little bit about that already, this is a successful proposal that went to the European Commission last year. This time they were busy with the evaluation of it, so we handed it in on the 5th of April, I seem to remember, and we started on the 1st of December. So this is actually a presentation of a project, but we did manage to put really all of these things into the project within only the 3 years in which we are running it, because it was a little bit mean from the Commission to tell us they wanted all of that and only within 2 to 3 million value. So let me tell you what our central objectives are. We are going to detect and characterize and quantify advanced materials during their handling and processing along the entire product life cycle. We are going to assess the potential impacts on human health and the environment by specifically defining so-called exposure points, which is something that we defined already in our proposal, and we said we are going to set those and follow those through the life cycle. And we are going to advance the widespread applicability of the development of test and characterization methods. Heard about that one already here. And their effectiveness and efficiency, specifically in the context of market-relevant industrial advanced materials. So there's two things in here. One is that we used to run test and test initiatives, so development of test guidelines, very much focused on nanomaterials. What we have decided here is to step up from the nanomaterials arena simply because we wanted to look at two-dimensional materials, and the graphene family has been excluded from the definition of nanomaterials. So in order to stay within all the correct definitions and policy recommendations, we had to step out and call ourselves a project that was looking at advanced materials, still keeping nano as one of the elements in there. And we are talking about standardization, harmonization, and technological regulatory validation. So again, it is a lot to take in, believe me. It was a lot to put into a 3-year project for just 2 to 3 million, as the Commission had wanted. But I'm going to walk you through this bit by bit. So first of all, here is our so-called MACRAMÉ. That's the acronym we came up with, our MACRAMÉ approach. And just one word of advice: never go for a acronym with a strange character in it. You're going to type yourself silly, unless you're from a country where your keyboards tend to be standard for this sort of thing. But we've done the damage, and I'm afraid we're blessed with it now, or cursed for that matter. So this is in essence, this is usually everything you need to know, but the picture is a little bit busy. So we're coming back to what we said at the beginning. We are going to look at real-life products. So we are going to actually work with 5 different products that we are plugging directly from the value chain, and we actually have a separate company involved behind every one of these. We are going to define exposure points. We have a whole raft of different characterization and imaging methodologies, and we're going to do human and environmental health impact assessments. And in the end, we are making all of this available to the standards community and the OECD through various, at least, applications of what would hopefully become later on a full standard or an OECD test guideline or guidance document. And I'm stressing application here because this process in itself, you hand in a recommendation and then either ISO, WAMES or CEN makes a fully blown standard out of it, or the OECD makes a test guideline out of it. That in itself takes anything between 5 and 7 years, and it is out of your control. So a real research and development project really only runs up to here, where you are handing in recommendations for, and that is why it doesn't say guidelines here, it says standard project submission forms. That is what the OECD calls their forms into which we as humble researchers may put our suggestions, and then they start thinking if they really want that. And they start talking to others, because the OECD is a member state organization. They need to decide by committee if there is sufficient need to bring that forward. So on everything that happens after this, the 7-year timeline that then starts in order to make it an OECD test guideline, that is something that a project cannot and should never claim to cover. But we have enough to do just getting all of this off the ground. So I promised you I would tell you where the mouthful of a title came from. So we are going to do in just this one single outline of a research and innovation approach, we are going to cover the fact that we are collaborative and we are doing research and innovation. I think that is pretty clear from the picture. We have shared responsibility in that you can see various different bodies in the picture alone. You have industry, you have a lot of research here, various different areas of research. There is a data science element in the middle of it as well. And we are working with the regulatory community. And we have safe and sustainable by design of the products and processes, which is derived from the fact that we are defining exposure points, and then we are looking at the real life cycle and we're assessing that. And the final aspect of the title is, it is a complex value chain, believe me. And if you don't believe that one already, then the next picture or the one thereafter is going to show you more to that one. So we are working with 5 market-relevant industrial use cases, and we deliberately call them use cases. They are not case studies, because they really are cases that are taken out of the use of the material in their complex value chains. We have a theme in there. It may look a little bit random, but our theme is 2D carbon-based materials and inhalable carbon-based materials. So what we have in there is we have graphene materials, and we sometimes only work with the graphene oxide or the few layer graphene. And then we used a different form of a graphene-esque material, which is the carbon nanotube, in order to have a variation of structure in there. And we then used, in order to fully test, we had one test system we wanted to further develop, and that was a specific lung model. And in order to fully test that, we also had to have something that we didn't know was already going to cause acute aggravation in the lungs. Hence, we used a carbon-based material that is inhalable, and that is the carrier for antibiotics. So 5 different use cases, and we're talking about the different aspects of safe and sustainable by design, life cycle assessment, life cycle costing here, material flow analysis, and risk assessment. All of this done on these 5 different value chains. This is what I said, this is where you believe these are complex value chains, and they get even more complex if you then want to do different forms of testing on them. This is what I would, or what in German you would refer to as a Wimmelbild. There isn't a very good English expression about that. It is like a teeming picture. So there's a lot of information in there, but I think the closest one that we have are the Bruegel pictures, where the main theme of the picture is that it is so incredibly busy. Nevertheless, every one of these characters here is really worked out with a minute detail and with showing its own character and telling its own history, that you really wouldn't want to miss any one of those. So how do you analyze a picture like that? How do you actually work out that what everyone is doing and what the entire history and the entire story behind this picture is telling you? The one thing you need to first define is you need to define the points that you want to look at, and then you need to define a language, and that is what we did. So we came up with a terminology, And we decided to call our different forms of material advanced materials, and then we decided to define the matrix. And we have a complex matrix, we have an environmental matrix, a biological matrix, a complex product matrix, and an end of life. That defines the stage that it is in, but it is very much after it has been incinerated. It also defines the stage of the matrix. And then we are defining our advanced materials at every one of these complex areas. And you can see if your advanced material is sitting in a complex product matrix and has been incinerated at the end of life, and you want to look at it in an environmental matrix, that is what you're all putting into one terminology. Put that on page 1 of your proposal so that it is absolutely clear what you're talking about for the following 44 pages. So this is what then defines our exposure points here. So we have defined our exposure points, and they are essentially given up here in these very fitting pink hexagons. You can tell the color pink is definitely going throughout the entire proposal and the project now. And we then defined the rest of the different sampling and the tests and characterization that we wanted to do with these samples as a function of where these different exposure point samples come from. So here you would see all of the characterization we wanted to do with every one of the sampled materials, and then some of them we are handing down into the human toxicity testing, and some of them are then handed down into the environmental testing. And everything, if you've worked in collaborative research before, you have a very long discussion about every one of those, and if a specific exposure point is going to go through all the way to the environmental toxicity testing or not, you can see that not all of them made sense to carry through into the environmental testing, but there is definitely a lot of thought going behind it. It's not only dotting a few dots on paper here. So this is the blue layer in the middle, was our characterization and testing. And just to show you a little bit more of what exactly we are doing, as I said, we are developing lung models. So we had a number of different lung cell lines and lung models that we're going to compare. There is a little bit of an estimate as to what the economic impact, if we were successful with really demonstrating that our lung tests are successful for this sort of material testing, we could make a big impact in the economics of testing these materials during their life cycle. And there is a whole range of different environmental tests we're doing as well, mainly on fish and on improving some of the other cell lines. If you have a specific question about this part, you have the expert in the room. There she is, our GEICA expert. So this now shows you why we are also accommodating safe and sustainable by design in these products. So we have the collaborative research and innovation. And one of the most important things about all of this that we are saying we need to define a terminology. We have a few dozen exposure points. It is no good if you've defined all that and then everybody goes away and notes down their measurement into a lab book, which is essentially pen on paper. So at the center of this is the exchange of data, is the exchange of the specific information that comes along with every one of these different samples I showed you. And that means into the center, we are putting the data center. And if you are not putting your measured data and your sample information, that means sampled on what day, so metadata as well, sampled on what day, in which quantity, how was it handled, what temperature was it stored under, all of this. If you're not putting that into a central digital database, the data simply doesn't exist. There's no such thing as to just writing it down at the beginning of your project, and by the end of the project, I'm going to transfer the result somewhere into a report and report it to somebody. Everything is digital, everything is shared, everything is accessible to anybody who needs to know, who needs to work with your sample. They can always follow back the sample to the specific place where it came from, and at the same time see all of the data that was acquired while you were doing so. And what that looks like is essentially a form of the verification, and we've just published the report on that one. That is a first and initial concept as to how is it all going to work, what is our plan to, how are we going to do this over 3 years. So this is what we are calling a data shepherding. It is a little bit of a, some of you may be familiar with the concept of a data stewardship. That is the person that tells you how data should really be stored and handled. And the shepherd is actually even a little bit more hands-on in that they are guiding the data, they are storing the data, guiding the data, and making sure it is safe. And actually from time to time looking in on how good is my database still, is everything okay, or do I need to change something? And also being very reflective on how they are running their database. So the shepherding service includes an awful lot more. If you're interested in that, as I say, we've just published a report on that. You can follow that up with the QR code on the next slide, I believe. So this is what it looks like when you are then working with your data shepherd, in that you are sitting together and you are drawing up an instance map. At which point are you doing something to your sample? I can make that a little bit bigger. So what you can see here is you're deciding to send a sample to the partners. You're deciding which partners these are going to be. They are in blue here. And then your partners are telling you what are they going to do with that sample. And they are, so the tests are done in red and in orange here. And then depending on what it is you're going to do, you pick a different color, because you then need to potentially send it on to, once you have done something with it, send it on to another partner. And this is what we're calling an instance map, and that means that your one sample, and that is 5 grams you are sampling today. The 5 grams you are sampling tomorrow will need a new one of these instant maps, because you will have a different, you can copy paste many of the parameters, but you will have a different metadata. And only like that can you actually then be sure that you know exactly what happened to your sample when it looks different from all of the other samples. And that is how you find out weak indicators of things that don't quite fit together. And quite often that is hidden in the metadata. And that is essentially, all of that is organized here through our information hub. Behind that is the central registry and all of these instance maps that I just described. So that is the article where we've just published it. As I'm saying, that is the article that is the initial concept of how we are going to do this. If you tune back in 3 years' time, you're going to get the report on how it all worked out. And I'm sure it's going to be successful. We have already started with quite a bit of pushback from our partners about, oh, really? Do I really need to learn a new data tool? Do I really need to learn a new digitalization of my data just to do what I always used to do? But in the end, they really come around to the idea, because you quickly lose oversight over so many different samples. And you also, through this thing only, give them the opportunity to work out small differences and see patterns in running your tests and acquiring your data that you would otherwise not have. So almost finally, and I'm now on shared responsibility and collaborative research and innovation. Obviously, none of that is possible with only a small group of people. You need a very, very large group, or a sufficiently large group to have all of the expertise covered. And you also need people who are willing to work together and are taking responsibility for their specific part in the work. So you can see here the mastermind behind all of the drawing board, as we are calling it, is Bioanalytic Münster. The proposal, so this was a Horizon Europe proposal, which means 45 pages. There is no way you're going to write the research plan for a 3-year project into 45 pages and also write down what the impact is going to do and the excellence part as well. So in the end, you are left with about 14 pages that tell you what are you going to do exactly for 3 years. Not enough. So that means that every project we're starting now, we're starting off with a redefinition and reconfirmation of a detailed research and innovation plan. And we are putting down milestones and indicators to measure at specific points in the project. Have we reached them or have we not reached them? Your project outline of 45 pages is not long enough for that. So we are calling that one the drawing board here. So that is the collaborative strategy setting and reconfirmation. We are then having all of our samples essentially looked after. These are the separate companies that are providing the samples, and we have them looked after by Thema Solutions in Switzerland. And they are obviously working together with the demonstrators, because our demonstrators are essentially our use cases working on the real value chain samples. And as I was saying, we have Geica here who are running this one specifically, and also supported by EMPA from Switzerland. We have a whole range of people who are working together in the characterization. Of those in the room here, or at least at this conference, you have RIVM, supported in many of these measurements also by Bauer, but Bauer is here indicated as one of our main agencies that is then taking our suggestions and recommendations to the OECD and to the other decision makers in regulatory context. And our big data partner in the middle is 7past9, together with the University of Birmingham. And I'm only here to talk about it and pretend that I know what it is all about, and to travel the world and tell you a little bit more if you want to find out more. So this is, again, to hit the message home that we are collaborative and we are sharing the responsibility throughout this really, really extremely short project that is aiming at a lot of things. We are 19 partners from 10 different countries, 3 different material families, but with the central theme of them being inhalable, being carbon-based, and working on 5 market-relevant industrial use cases. We started 7 months ago, and tune back in 3 years to see what came of it. Thank you.
So I can actually start. So because I noticed you had, I mean, at least to me, when I started looking at it, you had, let's say, graphene-like materials, and then you had the carbon nanotubes. And that, for me, at least from a safety point of view, is also 2 quite distinct families, because the carbon nanotubes are kind of known for they have this nasty long structure, which, I mean, it's not totally asbestos, but we're a little bit in that. And then you have the graphene, which is different. So is that also a way of viewing it, or I mean, for me, the carbon nanotubes stand it a bit out from the rest.
There is the so-called fiber paradigm, and the fiber paradigm means a fiber causes cancer in the lungs when the macrophages can no longer engulf it. And engulfing a fiber means it has to be flexible enough. So if you take a single cooked spaghetti, you can roll that up, and the spaghetti on the macrophage level, God knows what that is going to be. But the macrophages can essentially roll it up and then can swallow it. And usually the understanding is that they don't have any problem with that once they get fully around it. The macrophages have a problem with uncooked spaghettis, where they are trying to engulf it and roll it up, and it doesn't actually bend. And the macrophages dies hanging on to this very, very rigid thing, and causes the granuloma through its own endocytosis in the lungs while it is doing that. And that is the fiber paradigm, that you need to have a specific aspect ratio and a rigidity in order to meet this, what we perceive as the real, what you said as the asbestos-like behavior. Now, in order to fully clarify if that is true, we were thinking we use the same material and use it in graphene flakes, because that doesn't have that fiber problem, but it would help us to understand if the flexibility of a fiber really makes it better to handle for the macrophages, and therefore we can prove or disprove the fiber paradigm. And that was especially why the carbon nanotubes were a good idea in comparison with the flake-like graphene material. For me, the odd one out really is the inhalable antibiotics, because that really is a completely different particle, where we just said, and we need something else that is not going to possibly be toxic at first inhalation, because we want to see if you do inhale it and it goes somewhere else, does it then cause something somewhere else in the lung tissue? So we needed something that could get through that first barrier of acute toxicity.
Thanks a lot. This is really, I try to find words to describe it. Multidisciplinary, challenging projects, really very good. My concern about this data shipping, This is really important when you mention it because this is huge. You have a lot of data. And I think if you didn't manage in this way, which I didn't understand it quite, it will be somehow lost in between 5 different topics, difference, and many partner. I think this is quite important. It will be nice if you can comment simple words that I can understand it. Thanks.
Well, the simple words are, it is incredibly complex, and not only is it complex, it's also something where people would usually say, oh God, I really don't want to do that. I signed up to this to do a toxicology test. I signed up to it so that you give me a few grams of your materials, I throw it at my test lines, and I then tell you if they die or if they survive. So this is really what we needed to do with the researchers at the beginning, saying, no, we've done enough of that. We've done enough of that, and we've done enough of project closes. Everybody looks at each other and says, now what? Where is our data? Can we share the data? Can somebody else use the data? And we have that every time again. So what we were saying is we're actually, we wanted to turn this whole thing around and say we don't do anything unless it is a data point that is findable by everybody, including our own project consortium. And as I said, we started about 7 months ago, and Isabel, if I'm not listening, can probably tell you a little, 2 rows in front of you, can tell you a little bit more about that, because she's at the receiving end of having been sitting through 5 or 6 different sessions now about how do you catalog your data in the online system. And it is tedious, and it really makes the researchers lose the will to live. But after a while, every one of them comes around and says, I see the point. It means that when I pick up a sample from that lab over there, I know what happened to that sample before. So if I open that sample and it turns out to do something that I didn't expect, I may just log in online and find out, something have happened to this, or has it been treated in a way that hasn't necessarily been communicated up front. But yeah, that's exactly it. We are in month 7, and we are still on how do you catalog your data. Point proven, yeah?
Great. Oh, does it work? Great project. I think that graphene community was waiting a lot for such type of projects. I also like the idea that you will basically be related to the graphene, in this case, products. But just to make it clear that the outcome, will that be related to the, let's say, the water filter, or which is produced by this company, or will that be related to the water filter using graphene? And what happens if there will be another graphene supplier? Will that be still valid?
What it will be relevant for is the water filters using graphene, because our aim is not to test everything that one might to know, and even more out of a single material, let it be ever so relevant or not. Our aim is to, in the end, hand the regulators, we had this question earlier, the regulators a description as to, if somebody comes to you with a water filter that contains graphene, make sure you're asking them for that and that and that test, because if these have been done, and if these have been done to these protocols, then you can surely say safety has been proven. That is in very high inverted commas, because you never prove absolute safety. But what we are giving is we're giving the regulators the protocols that they need to look out for, because there's nothing worse than for the entire water filter community, no matter if you put graphene in or you've put gold particles in or whatever you want to put in there, then if your regulator says that's all very nice, but I have no idea how to prove that you can use that or not. So that is what we're doing.
Okay, thank you. If I understood you correctly, that you said your work finishes when it's translation into policy standards such as the OECD, and that's when you use Bauer to liaise that idea or information you have.
And our IVM.
And our IVM. What I was thinking about that in the Horizon 2020 project, there was EuroNanoForum, which was dealing with looking at endocrine disruptor toxicity and developing type of methods. And what they were able to do with some of their particular tests, which they thought should go to the OECD, they used a French platform called PEPA, which was a pre-validation platform. I'm not quite familiar with all the actual details of that platform, but it was a way of maybe a bridging a way into the OECD, as an example. If that is correct in my interpretation, do you think there could be a central function for a bridging platform for any type of method or test?
If you hear a champagne cork popping, then that is Monique over there, who essentially made the link to Pepper for the work on nanomaterials. And yes, it is a very good example for that. However, Pepper is only on endocrine disruptors, and it can only be an example as to how you can do this. And the next thing then comes, well, if you want to be as big as Pepper and want to be as long living as Pepper, because Pepper started 2019 and is still now going very strongly, it means you are looking for additional money. And that was not something that was in the call text. So we would be looking, if we followed your example, the example of Pepper, we would be looking of sustaining this sort of thing beyond the project duration. And quite frankly, we don't need to do that because that's what the Malta initiative is doing. So they are already putting a community together that does the test guideline development for specifically nanomaterials, and hopefully we can now by saying, look, Malta, we are doing this for nanomaterials, but we are also now making it available for the graphene community. And now the gentleman who's, no, there he is, I'm going to send him in to say that this is the best thing since sliced bread that we do for graphene. We can do all that, so we don't have to invent it. But the truth is, you still need a member state to have this thing in hand, and ideally another member state to the left and to the right of their shoulder, and say, we want to take this forward as an SPSF in the WPMN and in the WNT at the OECD. Otherwise, you're not going forward with it. You can build 1 million platforms. In the end, you need to get it into mutual acceptance of data, which means you have to have the official OECD test guideline. But no, it's a very good suggestion.
So with that, let's thank Steffi again.